We're excited to be meeting again. We've got food in the back if you haven't already. Looks like most of you already found the food, so that's great. Any stragglers that come in, just please help yourself to the food, and we'd like to thank Workfront for providing it. We also like to thank Adobe for providing us this gorgeous space that we get to meet in. Like, I tell you, as organizers, we've looked at a lot of spaces. We have a lot of people that talk to us about wanting to host our meetup, but this is a really, really tough space to beat. So thank you, Adobe, for generously sponsoring their ability to meet here. So anyway, so we want to jump in. Today we got 2 talks lined up, and if you're wondering if there was like I switched things up on you, I did. We had our previous speaker, Brett Little, had something come up, and so he was not able to make it. But I figured you guys still wanted to hear about CSS, since that's what he was going to talk about. So I have my own thoughts that I've been thinking about for a while that I wanted to put together, and so I put together a presentation for you guys, and so we'll do that. And then after that, we have Jordan Last is speaking to us about this really long title. It says Bonds That Make Us Free, but it's about Angular 2, Redux, and functional programming. And also, Jordan, if you're here, I don't think that we've gotten you on the Connect session yet. So do we have Brian or no, Jason in the back? In the back, we got Jason here with his hand up. Just talk to Jason and he'll help you get set up. Okay. And if he's not here, then I guess we'll talk about ngconf. That'll be fun. Okay. All right. So anyway, thanks for coming out. We got a few things that I wanted to cover here. As always, we are a community-driven meetup full of volunteers, and that's how we operate. And so one of the great ways that you can contribute is to submit an idea you'd like to hear someone else speak about, submit an idea you would like to speak about, volunteer to speak about something someone else submitted, vote on other talks that other people have submitted, and say what you'd like to hear. Ultimately, this is driven by you. And the way that we do that is through a GitHub repository. And we have an issue for every idea that we have for something to speak on. There's already lots of great ideas on there right now. So if you haven't already, please log on to GitHub, go check it out. We're AngularJS Utah on there. Go to the meetups repository, pick something, and vote on it. We're really thrive on our community participation. So please go and participate. We would love to hear your input. Also, similarly, like I said, we operate on volunteers. We've been having the last 2 meetups. We've been having Justin help work the front desk. And based on your feedback on the survey that we sent out, I understand that more people want to get involved and want to volunteer. So please, if you're interested, we're going to have you do that. In fact, and the way that we're going to have you do that is we're going to set up a Slack team. So we wanted to have a way that we could coordinate, and sadly, just sometimes email is a little too slow paced to get things done, like coordinating volunteers and what we're going to be doing. So if you're interested in volunteering, join our Slack team. We've set up a Google form that will ping us whenever you try to join, so we'll send you an invite to the team. But there's a channel on there for volunteers, so join the channel, say, hey, I'm interested, and we will start talking to you, and we'll figure out what we can do. But similarly, even if you don't want to volunteer, just join the Slack channel and get on and talk about Angular, talk about the community here in Utah. We'd love to have you on there. We will tweet out this address later, so if you follow us on Twitter, you'll also be able to see it that way in case you can't memorize a 10-digit long random number just with letters in it. Okay. Along with that, because we are opening things up more to volunteers and wanting to be able to get more of you involved and interacting with each other, and we have a Slack team now. Along with that, we wanted to establish a code of conduct, and we believe that this helps make it a safe space for everybody involved. You read through it; it's pretty simple stuff. It's based on the Open West's code of conduct. So if you've been to Open West, then you've actually already agreed to pretty much this exact code of conduct already. But the basic thing is be nice, be courteous, and we can all have a good time. So again, you will see a link to that when you go to sign up for the Slack team. Okay, so with that said, we're going to jump in. And since I'm the first speaker, I'll hand it off to myself. Okay, so Brett was going to speak to us about CSS. It's a talk that I heard him give at the Utah JS conference last year. It was a great talk. It was one of my favorites of the conference. So I wanted to take a similar note and talk about CSS for those of you that came here to listen to that. I figured that what a better way to do that. So as I was thinking about it, and I was thinking about CSS and some of the kind of the state of my relationship with CSS and how it's been over the years, I kind of came up with this fall in love with CSS again. Again, by the way, my name's Matt Winchester, I think I said before. I work at Workfront. You can follow me there. But like fall in love with CSS again, that implies I ever loved it in the first place, right? And but the thing that I kind of posit to you guys, like, actually, yeah, at least for me, I mean, I can't speak for every single one of you, but I did like some of the ideas that CSS presented. It has really great intentions. Like a lot of relationships early on, a lot of good intentions going into it. Separation of concerns, the idea of separating out how we style and how we present, and how we structure our markup and where we put our logic and be able to kind of organize things nicely. And then you have things like the CSS Zen Garden. How many of you have seen the CSS Zen Garden before? Okay, so a good chunk of you here. If you haven't looked at it, go look at it. It is honestly a little bit of a relic of the internet at this point, but it's still actually very relevant because of the ideas that they push. But the idea with CSS Zen Garden was that they'd have the exact same markup, but radically different looks to their site based on changing merely a CSS file. And this was the power that CSS promised us. This is what we hoped for. This was what our expectations were built on. So in this relationship, CSS has made us a lot of product promises that we would only have to write our markup once. That your developers write the markup and your designers write the CSS. How many of you actually work in a situation where that's true? Okay, we got a few. I have not been able to be in that experience myself, and I'm glad to hear. I'd be curious to hear how you folks make that work. But in the world I'm at, it's the developer just kind of does all of it. A declarative style, that's one of the things that we don't think about a lot, but CSS actually is pretty declarative. It says, this thing behaves like this. And it doesn't go through and say, okay, I'm going to find this guy and I'm going to attach this stuff. It's a declarative style, which is something that we enjoy about Angular, and has actually been there for a long time already. You could swap out your theme. That was the CSS Zen Garden promise, right? That we can swap out our theme, and we can radically change how our sites look. But the problem with these promises is that CSS lied to us. Because I don't know about you, but when I look at all that stuff, that list there of promises that it made, I feel like very few of those ended up actually being true. And that CSS instead is something that I fear. It feels more like I'm playing a game of Plinko where I'm trying to see, well, I want it to go there. I'll try making a change here, and we'll just kind of see how it falls through. That's oftentimes what it feels like. And so we get into this situation where we worry a ton about when we're trying to do the work that we've been tasked with, how do we do it without screwing up what's already been done? And I know that I often live in this world where I'm changing CSS, and I fear what I can break. So what's the response to that? At least for me, the response has been to make very precise changes, very specific changes. Kind of like playing another game you might have played called Jenga, right? Where you're just trying to get the one thing and get it out right, because if you don't, you're going to bring the whole thing down. Okay, so this has kind of been some of my experience with the broken promises of CSS in my relationship. Once you start getting really specific, that brings on the great specificity war. How many of you are familiar with the specificity war? Okay, some folks have been battled in the trenches a bit. The specificity war goes like, I need to get this thing styled this way, but there's this other selector that's styling it, and it's more specific. And so I add on let's add on an ID selector and 3 more class selectors and an element selector just to make it strong enough that it overpowers the other one and I get the style that I want. And so things start to spiral, and of course, as is inevitable, war always eventually goes nuclear. And so it does in CSS. To be honest, it was funny, as I was putting the slides together, I was thinking, like, there actually are a lot of comparisons between CSS and war, which, considering that the motif kind of for my talk is that this relationship we've had with CSS, this is the breakup, right? Our war is the breakup. So there's dead bodies everywhere, or in this case, dead code. How many of you have ever run one of the analysis tools that allows you to look at the CSS on your page and see which selectors are actually being used and which ones aren't, and found that there's actually a lot of selectors that are completely dead? How many have gone through that? I know I have. And it's frustrating because then you have to take this selector, which was most likely generated by some preprocessor like SAS or LESS or something, and then you have to figure out, okay, where did this come from? How do I get rid of it? And then you have to be sure that even though it's not used on that page, it's not used on some other page maybe in your single page application. You just didn't load up the right route, and it's actually still very applicable. So it can be very hard to decide what's still working and what still isn't. You start to lose trust in the code base that it does what you think it does. And all of a sudden, all the other lines of code are threats to you being able to get your stuff done. And it really starts to become a battle just to get your features in and just to get them styled appropriately without breaking everything else. Am I the only one who feels like this, or are there other people out there who felt this? I'm seeing some heads, so that's good. Well, the thing is, it wasn't supposed to be this way. It wasn't supposed to be a war. Oftentimes, like a relationship we have regrets about, there's some regrets about CSS, but we went in with good intentions. This is what it was supposed to be like from the early days, right? They were supposed to go hand in hand. They were literally made for each other from the early days of the internet. Couldn't we just have it be something like this? I can look at this code, and it's a slide, mind you. Slides are not supposed to be very big. And they're supposed to be able to digest them quickly, and I can tell you exactly what's going on here. Okay, obviously I made up some actual CSS properties in this one. I've heard that it's in an upcoming spec, though. But that's the idea. It should be this easy to do, right? You should be able to just. We've already been told that classes, are the best practice of how to operate. And if everyone's using single classes, you don't have to worry about specificity. And it's really easy to just go like, oh, this message is being styled with a pure intent, and I can see it right there, right? Couldn't it be this simple? But it can't be. And why can't it be? Oh, because somebody else may have made a message selector. And there could be something else called message over there on the other side of the application. So how can you gain that certainty back? Is there a way we can get back to this? Sorry, I was going to point at the screen, realizing you guys can't see my... And I'm here to tell you that it can be, but it requires change. It requires adaptation, just like a relationship trying to nurse itself back to health. It requires change. So here's a proposal, something like this. Let's say instead of using straight HTML, we use JavaScript to write our HTML. And we're using some ES 2015 syntax, which I hope most of you are comfortable with, but just briefly looking at it, we have an import statement, which brings in, instead of a JavaScript file, our CSS. Okay? Then we have an element. We're just going to set the content of it. And if you aren't familiar with the backtick syntax, that's a template tag in ES6. It's a great new way of doing strings, and I highly recommend them in general. And then you got that little dollar braces syntax inside of the string means that we'll do some variable replacement. So essentially what this is saying is I'm just building a string of some HTML, and I'm going to take the class, and I'm going to apply it here. Now, and then on the CSS side, it just looks like CSS. There's nothing too crazy about that. And this kind of gets us close to that, couldn't it be this simple, right? That I showed you a few slides ago. And it's not exactly the same, granted, but it is similar. But there's reasons why this doesn't work right now, right? But there are some benefits that we can get. So all of a sudden now we can start to get certain about how it's used because it's a dependency that's brought in, that's stated explicitly in our code. And so we can go through, and if I have in that CSS file, say, another selector, and I know that I can see everywhere that this CSS file is used, I can go through and with confidence say, this selector is not being used anywhere. It's gone. Just like that. Okay? You get to have your simple class selectors back. No more need to go into this like super big hierarchy of specificity wars. Because you know where it's being used, you don't have to worry about overriding someone else's style because you have complete control at this point, and you know that they have complete control as well, the theoretical they. I think I already mentioned no specificity wars. Moving dead code. So I guess I'm just repeating myself at this point. But predictable behavior. You can start to see exactly what's going to happen, and you can read through it and make sense of it. Now, mind you, these are simple examples. I think we're still good on time, so I can probably show you an actual example in code. So there's some compromise, right? Like I said, we have to be willing to change. So the compromise is that we don't hard code our selectors, our classes anymore. Now all of a sudden we're using a variable to store it. I mean, you guys all saw that, right? It was style forget what it was. You let go of the global cascade, right? There are places where the global cascade is beneficial, like if you want to apply fonts to everything or reset everything to the box sizing border box or something like that. There are places where the global cascade can be beneficial, but overall, it's what's harming us. It's what was made for HTML documents when they were meant to be just that, a document, right? Like, oh, here's my travel log for the day, and you save it as an HTML file and put it up on your web server and never touch it again. It's not dynamically generated or anything like that. I just want all my anchor tags to look like this, and that's not as much how we operate. We do composition. We build together different components and bring them together and have them compose something greater. And then the thing that, and I'm showing my hand a little bit here, but is that it becomes generated class. Ooh. They're generated class names, which is why you have to reference them inside a variable. So how do we do this? CSS modules. And you can talk to some of the people I work with, and I'll be honest, I'm a little evangelical about CSS modules. I happen to really like them, but that's because Jason's nodding his head. But that's because I found that they solve a real problem, a problem that I have felt through the entirety of my career, which has been like not a short amount of time. So I wanted to show you guys some of this. So it looks like I got another 10 minutes or so here. So I want to dive into some code and show you exactly what this looks like, because I mean, a slide's one thing, but let's look at real code. So, whoa, that was not what I expected. Is that big enough for you guys there? Can you see that? Should I make it bigger? It's good? Okay. So in this case, I have a simple application. In fact, I'll even show you what it looks like. It's this one here. I'll bump it up a little. Okay. And you can see the HTML file is pretty simple, right? And look, and here's that global cascade I told you about. All right, I applied a font globally. I think that's roughly appropriate. Whoa. That's what happens. Turn down the lights. Okay, and then I'm bringing in one JavaScript file, okay? Now, I'm using Webpack. I'm not sure how many of you are familiar with Webpack, but we're not using too many crazy things. We're using Babel so we can get ES6, and Babel Loader so we can get it into Webpack. We're using the Babel preset, so again, we're using, or ES 2015, forgive me. CSS Loader is the magic piece that enables CSS modules, but the CSS Loader is not necessarily always the only way to do this. There's actually a specification written. It's not by a standards body, but there's hope that something like this could get adopted by a standards body that defines how CSS modules work. So in theory, we could have lots of different tools, and you wouldn't just have to use Webpack and CSS Loader. In fact, I think there's a post-CSS processor, but I could be wrong on that one. Style Loader for attaching it to the page, and then Webpack, like I said, and Webpack Dev Server, so I can show you guys what's going on. So there's not a lot going on here, and the Webpack config is just about as simple. It's There's not much here. I'll share a link to this on GitHub so you can look at it more in depth if you want. But suffice it to say, the main thing to get out of the Webpack config though is that our entry is index.js, and then it makes this dist app.js, which, if you remember from the index.html file, that's the guy we brought in. So our entry point really here is this index.js file. And then here we don't have too much crazy going on. We have a function which takes an element, and it will make a new toolbar, a new body, and a new footer, and then append each of them to the element. That's it. It's nothing too crazy here. And then I'm calling it with document body at the end. You could potentially make this like your module.export, or, well, I guess this is ex6, so you could export this function instead. And then you could reuse it in other places as well. For the sake of the demo, I just attached it to document body off the fly. And then I just have 3 components, if you will. They aren't defined in Angular, they aren't defined in React, they're just JavaScript. It's just really simple, and we'll look at them in just a second here. But we have 3 different components that we're using here. So let's just take a look at the first one. Toolbar, index.js. So here's that first line that I mentioned before, that like, wouldn't it be nice if we could just bring in our styles? Well, this is one of the things that CSS loader actually allows us to do. It will bring in our styles, and it will go through, well, here, I'll show you in a second. We'll come back to that in just a sec. But the other thing I'm doing is I'm exporting a class. It has a constructor where it creates an element. It puts a class on it, in this case, styles.header. So you'll notice styles comes from styles CSS. So that's one place where we're using it. And then we set our inner HTML, again, similar to what you saw on the slide. And we do styles.text. And then it's just a span tag, like nothing too crazy. And then we have this little get element thing, and that's just for convenience of bootstrapping it later. So nothing too nuts here. Is everyone on board with me still? Anyone left behind? Okay, all right, we'll keep going. Okay, so let's take a look at the styles class. So remembering here, we're bringing in the styles. We're expecting there to be a header and to be text. So we look at styles CSS, and we have a header, and we have text. And we have styling on them, just like you would do if you were writing CSS, just plain CSS, no preprocessor. In this case, it's a simple example, so we can do that. But you could potentially do this with a preprocessor as well, as long as you know what the end class names are. Which admittedly kind of takes away some of the need for a preprocessor, at least for nesting and things like that. Anyway, so you'll notice here we have header and we have text. And those things are made available on an object. As you can see back here, we have styles. Whoops, sorry, not here. Back here, my apologies. Back here, we have our styles object. And so the key is the same as whatever we define in the CSS module. Now, what's the value? The value is who knows what. It doesn't matter, actually, what it is. Because it's going to be some generated string that's unique. And the reason why this is awesome is because it means that somebody using another component can't just grab it and start using it without you knowing about it, without explicitly depending on it, without having a way that there's a trail that you can find that file when you go to try to make changes to your CSS. You can see what effect it'll have and which files it'll affect. One of the other neat things about CSS modules, you can still keep using, I'm using keyframes here. If you look over at the demo, I think this was the title one, I got a little fade animation on there. It's super impressive. I know, you can clap now. And just some positioning in this case. There I'm doing the animation. Just some little things. It's nothing too heavy here. And you'll find if we look at the other ones, it's more of the same. So let's take a look at body. Bodies, there's a little bit more going on. You'll see I got some pre-tags with some code in them. But as far as how styles is being used, I have a CSS class I'm using, a JavaScript class I'm using, and I have this styles.body. So there's 3, CSS, JavaScript, and body. And we come back and look at styles here. And you can see, all right, here's the body. We can see that we have a margin top. We're using Flexbox, which is pretty great. And then we got the stylings for our JavaScript and CSS that you can see over here. In fact, actually, if you look at this, there's some commonalities here. See, I don't think I have my server running actually at the moment. Let me start it up real quick. But you'll notice that actually the border, the padding, and the width are all the same between the CSS and JavaScript ones. So what I'm actually going to do, I'm going to cut that, and I'm going to come up here, and I'm going to call it .code. I'll put that in there. I'll get rid of this one too. And now I can do composes code. Composes code. So let me do that. Come back over here, and it won't look impressive because it's going to look exactly the same, but actually that's kind of the point, is that I refactored it and broke nothing. But that's one of the things that CSS modules gives you, is the ability to use composition to build your classes together. So that way I could, like, if I wanted to change these from black to green or gren, which isn't a real color, now they're green. I don't know how well you can see that on the Hangout, but they're actually, or on the Connect, but they're actually green, I promise. Here, make it 10 pixels. That'll stand out, right? Boom. Okay. All right, so that's this file, and then you'll find that the footer is really just more of the same. If we go to the footer. Again, just a simple thing. We're using text, we're using footer. Go to our styles. We have a marquee. We have a footer. We have our text. We have a little more complex selector going on, and it works just fine. In fact, you'll notice I called it marquee, right? So here's the bringing a marquee back. Okay, all right. So that's pretty much my demo at this point. I think I got a few more. Oh, I'm almost out of time entirely. That's it. That's what I had. Any questions? Anything? Anyone? No? Okay. Oh, wait, we got one back here. Does someone want to work the mic? So we get it on the Connect session. Thanks, Jason.
Forgive my somewhat ignorance. I have never really used Sass, but it just seems like, although you have a programmatic, there is a programmatic approach to it as opposed to just a composition approach. It seems like it would suffer from the same issues as Sass.
Which issues are you talking about?
Just with the nesting classes and files getting, and the name, the selector is getting really, really long. And
are you talking about this one right here, kind of? Because so far, because this is the only one with a nested selector. So
I was thinking about the compose.
Oh, you're talking about compose.
Composing, yeah.
So composing, that's a good question. To be honest, composing is kind of cool. I'm not sure that I have the most positive feelings towards it yet. I think the coolest stuff is more the map of generated class names. Okay. But let's see, would you have the same problems? Let's see. So it would add them both to the element. So it would have both generated classes, because that's how it does it when you do compose. It brings it in, and then it actually generates two classes, and they both get put on it. You can't tell the difference behind the scenes. But and then the CSS it generates would still have two separate ones. So the specificity on each of them would still only be one class selector. So I don't think you would, but I might not be thinking it all the way through.
Okay. Well, sounds cool.
Thanks. Oh, back here. Do you guys want the lights back on, by the way, or is this, do you like this? I'm not hearing strong opinions either way, so.
A comment about the last the issues. If I understand it correctly, I think with Sass, you're still dealing with this global styling like you do with CSS, where isn't this fully modular and the names are munged just for that one component, and so you get more of a local component-based styling?
Yeah, it's definitely more modular because the names are munged. And so the only file that has access, where was the one that we did code on? That was the body, right? So in this case, this code class wouldn't be accessible to anybody else to use in any other class. Except there's actually, again, this is further down the rabbit hole of CSS modules and more stuff that I'm kind of like about how I feel. But one of the things you can do is you can actually have one CSS module import another one. You would basically, if I had this code thing in a separate file, I could say import code from, oops, not from. I make that mistake 20 times a day, I swear. And I could say code.css or something like that, right? So you could actually import it from another file. But again, it's a defined dependency that you can follow the trail, and anybody who doesn't, it's a munged name they can't get access to. I like that word, munged. Go with that. Was that a question or kind of just a
comment about
okay
issue or benefit? It's another benefit of the
Okay.
CSS modules.
Hey, what else we got?
So how does this look in the browser when you're trying to work out what style to change to fix something? Do you get source maps from Webpack?
Okay, so that's probably one of the biggest things about CSS modules at the moment is that source maps source support is not the best yet. However, you can do some stuff. What I will show you in the Webpack config here is that you can change actually how it generates it. And you could change, like, you could have a different Webpack config for production if you really want it to just completely be random. But you got to give it the name, the local, and then the little hash. So if I come in and inspect it here, you'll see that the selector on it, it's styles, so you know it's from a styles.css. In my case, I have tons of style CSS, but you can add the path, you can add other things. And then we know that the name of the class is called JavaScript in this case. And then again, you can see it uses styles code. So you can have it generate a selector that can help you. I admit it's not as good as source maps. But I would love to see source map support come in the future. And I think in this case, the benefits outweigh that particular drawback, but that's a great question. Anyone else? I think we can do one more before we hand it off to Jordan. Or we could just hand it off to Jordan. Okay, thanks, guys. Oh, here. Sorry, they didn't get you rigged out.
Okay. Is it working? Yes. Okay. Hello, everybody. I'm Jordan Last. I go to school here at BYU, and I like JavaScript a lot. Question before we begin. Who does any functional programming in here? Okay. Cool. Has anyone done Redux? Okay, a couple of people. Okay, cool. I guess I'm just going to share some of my thoughts on function programming in general. I mean, I'm still a beginner at it, I would say, but I feel like it's been helping out my applications a lot, and it's easy to kind of reason about things, and I guess I'll just share what I can with you. So I entitled it Bonds That Make Us Free, Healing Our Code, Coming to Ourselves. I feel like Sometimes we think rules are something bad, something that restrict us and keep us from doing the things that we really want to. But it turns out that rules are actually good, especially in code. If we can restrict ourselves to doing only certain things, only writing code in a certain way, then we can get certain guarantees in our code. That helps things become easy to maintain and helps code grow in a maintainable manner. And it just helps you keep your whole program kind of in your mind so you can see kind of how data is flowing, how different things are interacting with each other. And like I said, restrictions can free us. So let's talk about some restrictions that we can impose on our code. Oops. Okay. Think of the most unstructured JavaScript code you could imagine. I'm thinking of one file with like 10,000 lines of code, like a medium-sized application. So you're doing all your DOM manipulations and everything and just doing HTTP requests and everything in one file. It's what they call in Italy spaghetti code. And it's unmaintainable. And you're going to have to scroll through everything, and it's just hard to deal with. So let's impose a restriction. First thing we could do is split everything up into functions. So you can think, okay, this functionality looks similar to this functionality. Oh, let's pull that out. Let's wrap this up into a function. Great. Okay, so now you have 5,000 functions in one file, which might be slightly better, but still probably hard to deal with. If you're doing object-oriented programming, you have some more tools, some more restrictions you can put on yourself. You can split things up into classes, and you can start taking your functions and thinking, okay, these functions all kind of deal with the same domain, make a class out of it, and those functions then become methods on that class, and you can instantiate objects, and you can start working with your program that way, which I think has worked pretty well for a long time. Most of us are probably familiar with object-oriented programming, and it does make it nice to think of things in classes, give them kind of a name. You can kind of identify relationships between things. Can we do even more restrictions? That, to me, partially, is what functional programming is about. Let's constrain ourselves even more strictly so that hopefully we can free ourselves even more because we get certain guarantees. So in a functional program, your basic unit is the function. We just talked about functions in object-oriented programs. So what's the difference here? These functions are special. These functions need to be pure. What does it mean to be pure? A pure function has no side effects. It does not change the outside world. So let's say you have a global variable. In your pure function, you should not change that variable. You should not rely on that variable. Also, you should not do HTTP requests inside of your function. That is talking to the outside world. You should not write to a local database. Everything you pass in, you should only deal with what you pass in and return a result. So that's the first thing, no side effects. The second thing is idempotency, which means if you have a set of parameters that you pass in, your function will always return the same result. So for the same input, you get the same result every single time, no matter how many times you call the function. So a simple example would be if you pass in 5 to a function that multiplies it by 2, and it returns 10, every time you pass in 5, it will return 10, infinite times. How would a non-idempotent function work? Let's say you pass in 5, but you rely on some kind of global variable, or you do some kind of HTTP request to get some data that you need to then add to the number that you pass in. That would not be idempotent. It might change And so it makes it a little more difficult to reason with functions like this because you don't know immediately, based on what you pass in, what it's going to return. And you should think of a functional program as a collection of pure functions. So in JavaScript and other functional languages, I'll speak to JavaScript because I know that one for sure, you can nest functions. And those functions can nest functions within themselves. You can also pass functions in as parameters. You can also return functions as parameters. That's known as higher order functions. So you can make entire applications out of these pure functions. That's always been kind of abstract to me and didn't seem super practical because I was like, well, I don't get how I can just put functions together and make programs. So let's talk about Angular 2 specifically. If a functional program is a collection of pure functions, an Angular 2 program should be a collection of pure components. Because an Angular 2 application is a collection of components. It's a tree, right? The root component can have children, and they can have children. If you make your components pure, though, then you start getting the benefits of functional programming. Things start becoming deterministic. If you pass certain data into your components, you will always know that the component will render the same thing to the screen. So conceptually, what is a component? Components tie together UI and behavior together. So it's a very intricate connection between UI and behavior. In Angular 2 specifically, our UI is described with HTML, and our behavior is described in JavaScript. So you have a view and a controller. So that's a component. How would we make this component pure? Well, you pass data into the component first. So let's just imagine there's some raw data just coming in. We can data bind that data into our template, and we can do this in a pure way as long as we make sure that we don't have side effects. So between the data coming in and between setting those variables to go into the template, don't do crazy things like whatever crazy side effect thing you might do. And if you do that, you should always render the same thing every single time. So given a certain input to your component, you should always get the same UI rendered to the output. So that's one component in isolation. And that's how you can make that one component pure. But as we know, with our applications, there's lots of data to manage. We have state that we need to manage across all of our components. And you could have tons of components. And it's kind of easy to talk with your children or to talk with your parents. Children can raise events up to their parents. Parents can access their child nodes. So that's kind of usually not too difficult to do. But how do you talk to siblings? That's always been, especially in Angular 1, that was like a problem I always ran into. Like, how, if these aren't connected like straight up in a hierarchy, how can I get to my siblings? Redux really helps simplify this for us. It is an immutable object store. It helps maintain your state across your entire application. And the cool thing about it is that it's very simple at its core. It has a few very simple pieces to it. And once you understand those pieces, then your life becomes easier. So here's our little case study. We have a component floating in the top right corner in a sea full of blue. So our component's just sitting there. It's waiting for the user to interact with it in some way. And pretty much all interactions, most of the interactions with our components are going to come through some kind of event that the user raises. So the user is going to click something, or they're going to type something, and then you'll raise an event. Okay? So our event comes up. This is coming from the outside world. So the outside world is talking to us. This is a side effect, I guess, coming into us. Okay? We're going to have some kind of handler for that event. So in your Angular 2 class, you'll have a method that you hook up to receive click events or input events or whatever. Okay? Now we start the process of dealing with this event and any state changes we need to make in a functional, pure, deterministic manner. You create an action. So this is Redux specific now. You create an action. Your action is a simple, plain, it's just a JavaScript object, plain old JavaScript object. It has a property called type, and you give your action a name. So like change username, or update comment, or add blog post, or whatever. You pass that action to a reducer. A reducer is a function. It's a pure function that takes an action and takes the current state of your application and returns a new state. So this diagram's kind of weird, but that state right there is also a plain JavaScript object. And there's one state for the whole application. All components can subscribe to changes on that state. And all components can mutate that state by generating and dispatching actions. And so this really helps synchronize everything. There's only one way ever to change the state. And you have to describe explicitly, I'm making this change with an action object. And your reducer takes that action and takes the current state and in a pure manner without side effects, and you need to make sure to do that, returns a new state. Okay. And all components can subscribe to state changes. As soon as the state changes, it passes it on to everybody who's subscribed, and then the component renders again. If you notice, this is what we call unidirectional data flow. There's only one path for these mutations to take. Your event gets raised, you capture it, and then from the action all the way to rendering, one path. And you can follow the path really easily. You can log your actions. You can log your state before the reducer and after the reducer. And then it just kind of becomes easy to debug things because you've restricted yourself. Only so, because of these restrictions, you now have guarantees. This is very deterministic if you write it correctly. In fact, it's a finite state machine. It's a deterministic finite state machine because the reducer takes, if you've taken a computational theory class where they make you draw little machines, it is one of those, I think. Okay. Let me show you a code example. This is not perfect Angular 2 code. I've left some things out, but should give you an idea. Can you see it? Good? Okay. So here's our component. It has a template, which is the view. It has a controller, which is this class down here. The template has a few variables that we're data binding into. So we have the username that should appear in that div. And we have an input element. And we have a button. And when you click the button, it's going to fire this handler. So this is our event handler. And it's going to grab the value of our input, and that's going to be our username. So just pretend this is like a login, some kind of login screen. Okay, let's trace from the moment we click login to that username being updated. And sorry, I don't have a, you'll just have to conceptualize it. Okay, the user clicks the button. The handler gets called right here. We make an action. It's just an object. You put a type on it. I'm describing my mutation. Username has been changed. And then I'm going to pass in data with that action, the username. And then, if you look up here, I have dependency injected my store. And I just store it up here in this variable so I can use it down there. And then I subscribe. Sorry, this is the constructor. This is before we clicked login. I've subscribed to state changes by passing in this function right here called map state to this. Okay. So the user clicks login, create the action, and then right here we dispatch. The dispatch goes out to our reducers. So here is the root reducer. It pretty much composes, I think it's the right word, all the other reducers. So we're going to switch on action.type. And what do you know? Here's our type. We're going to copy our state. This helps make it so that our function is pure. I'm going to copy my state. And now all my changes to my state are local to this function. I'm going to set the username property on my state object. If you look, we imported the state object from this file. So there's the state object. Just an object, just has a username property. In a more complex application, you might have for everything that you want to manage, all of your application state, you're going to put into this object for your entire application. So if you have a list of movies, you'd have a movies property, and it'd be an array or an object, either way. And you would update with actions that property, and you put things in it. And so you can have the username. Yes? Yeah. Yeah, so you don't want to mutate. So we can't have side effects, right? So we cannot change the outside world at all. That is what this line right here is doing. It's stopping us from changing the outside world. Object.assign is going to copy the state into a new variable. Now that it's in that new variable, I can do whatever I want to that variable, and it's not changing anything outside. At least that's my reasoning for doing that. So, and you could use immutable JS to do stuff like this. I just like doing, in the Redux tutorials, they use object.assign, so it's nice. Yeah, so here's a state object, and it can get as complex as your application needs. And this is just where you're going to store everything. So blog posts, comments, your username, your email, whatever that you need to distribute across your application. Okay, change that state object that I copied. This is now a new state, and I return the new state. Redux is going to see that I returned it. It's going to call all the components, all the functions that the components have subscribed with. So all subscribers are going to be called. This component happens to be one of them. And all we do is grab the current state as it is, and then we set our template variable. Well, this .username is going to be data bound into the template. We grab the property from the state that we want, and that will render into our template the username. This is deterministic. It's unidirectional. We can follow everything that's happening. If the user types Dan as a username, it's going to be Dan every single time. And as you scale in complexity, the hope is that this will help manage all that complexity. Yes? Yeah. Yeah, you can absolutely break it up. I haven't needed to so far. We were probably getting to the point where we wanted to in one of the apps I was working on, but you definitely can. Strategies for it, I think you can just put, if you read the Redux tutorials, they talk about it, and I'm sure you could put things in different files and import them and stuff. So, okay, so if you want to learn Redux, go to the official docs, read those, and then do the Egghead IO videos that Dan Abramov, the creator of Redux, the ones that he made. They're all free, and they're super awesome. Like, they're really good. So, any more questions? Yes. So Redux is an implementation of Flux. Flux is the paradigm that Facebook has come up with for unidirectional data flow and state management. So there's other Flux implementations. I guess you could call them competitors. I don't know of specific ones. Elm and Redux are pretty much the same concept from what I understand. Elm is an entirely different language, but the way that it handles state in its applications is pretty much the same thing as Redux. So if you want to use a different language, Elm is, I guess you could call that a competitor. But it seems to me like Redux is the only one doing this specific implementation of Flux, I guess. So if there are no other questions, I'll just finish up. Key concepts are your Angular 2 app is a collection of pure components. You have a single object that is your entire application state. Describe all your state mutations with actions, and hopefully this is going to make things easy to reason about. You can kind of keep the application in your mind, and you can go step to step and see how things are changing, and that should make it easier to debug. And hopefully you take away from this as well, this is not Angular 2, well, of course it's not Angular 2 specific. Flux and Redux are traditionally used in React applications, but any kind of program where you have like a component-based model, so React, Angular 2, Angular 1 if you're doing it in a component-y way, or web components, or you can even use Redux for other kinds of applications. I was doing a project in one of my CS classes where we were implementing parts of TCP, the protocol in the internet stack, and I used Redux in Python to help me manage that. So you can kind of use it for anything that's getting a little complex with its mutations. So that's pretty much it.
Probably should have brought a mic down with me. Okay, thanks, Jordan. Again, thanks me for speaking. No, mostly like thank you our sponsors again for making it so we can have these awesome events. Thank you all you for coming. Like we say, this is a community event, and we're really